students, I hope all of you are doing good. Let's start today's chapter, cubes and cube roots. After reading this chapter, you will be able to know about all these topics. Okay, introduction. In the previous chapter, we have learned about squares and square roots. Now we are going to learn about cubes and cube roots. We have seen that the squares of all numbers are positive. However, cubes of positive numbers are positive and cubes of negative numbers are negative. Also, we can find the cube root of negative numbers. Remember, square root of negative number is not a real number, but cube root of negative number is a real. Why? Cubes. The cube of a number is that number raised to the power 3. Thus, if a is a number, then the cube of a is a3, which is a into a into a is equals to a3. For example, 3 cube is equals to 27 and minus 5 cube is equals to minus 125. Now, you have got the answer of this question. Why? Okay. Similarly, 4 by 3 cube is equals to 4. We will multiply 4 3 times and then we will multiply 3 times. So, we will get 64 by 27 and minus 1 by 2 cube is equals to minus 1 by 8. Okay. Cubes of natural numbers. The cube of a natural number is that number raised to the power 3. Thus, 2 raised to the power 3 is equals to 8 and 6 raised to the power 3 is a 216. Perfect cube. A natural number is said to be a perfect cube if it can be written as cube of some natural number. For example, 125 is equals to 5 into 5 into 5 is equals to 5 cube. Similarly, 27 is equals to 3 cube and 343 is equals to 7 cube, right? In order to check whether a given natural number is a perfect cube or not, we find the prime factors of the given number. Then group the factors in triplets. Okay, this time we will form the group of triplets such that all the numbers in the triplets are same. If no factors are left in the grouping, the given natural number is a perfect cube, otherwise not. For example, 392. Okay, we will make the pairs of triplets. Here is a one pair, but this is not the pair of triplet. So, grouping the prime factors and triplets of equal factors, we find that 2 occurs as a prime factor of 392 thrice, but 7 occurs as a prime factor only twice. Thus, 392 is not a perfect cube. Okay. No more. Find the digit at unit place when cubes of following numbers are obtained. Okay. These numbers, and hint is given. Find the cube of digit at unit place and the digit obtained as at unit place will be the answer. For example, 78 cube. Okay. So, 8 into 8 into 8 is equals to 512. So, 2 will be at units place. Okay. Similarly, you will find in example 2 cubes of 30. Cube of 30 is what? 30 into 30 into 30. 3 into 3, 9, 9 into 3 is 27 and we put 3 zeros. Okay. No more. Cube of even number is always an even number and cube of an odd number is always an odd number. Okay. Let's do exercise 7.1. Find the cubes of the following numbers. Okay, you can easily find out. Cubes of 9 is 9 into 9 into 9. 9 into 9, 81. 81 into 9 is 729. So, the cube of 9 is 729, right? Cube roots. To find the cube root is the inverse operation of finding cube. We know that 27 is equals to 3 cube. So, we say that cube root of 27 is 3 and it is written as like this. 3. Okay. Example 6, find the cube root of 13824 by prime factorization method. Okay. So, these are the prime factors given. See, 2 into 2, then again 2 and then 3. So, 2 into 2 is 4, 4 into 2 is 8, 8 into 3 is 24. So, this number is the cube of 24. Okay. No more. Sign of a square root is this. It is not needed to write this. Okay. Example is given. And number 2, sign of cube root is this. This time you will write 3 here. Okay. Now, cube root of a cube number. If we know that a given number is a cube number, then we can follow the method given below to find its cube root. This method is mainly used to find cube roots of bigger number, especially of 4 digits or more. For example, suppose we have to find the cube root of this number. We divide the given number into groups of 3 digits starting from the rightmost digit of the number. Okay, for example, we have this number. Okay, 175616. We will make pair of 3 but from the right sides. Okay, so 1 2 3 1 2 3. Okay, this is first group, second group. Step 1. First group will give us ones or units place digit of the required cube number. The number 616 ends with 6. We know that 6 comes at the unit place of a number only when its cube root ends in 6. So we get 6 at the unit place of the cube root. Means there is a 6 for sure at the unit place. Step 2. Now we take another group which is this 175. Okay, we know that 175 lies between two cube numbers, between 125 and 216, that is 5 cube. This is the cube of 5 and this is the cube of 6. Now 175 is greater than 125 and less than 216, right? So smaller of these cube numbers will give us the tens place of the required numbers. That is, tens place in the cube root of the given number is what? 5. So we will write here 5. Okay, this is the shortest method of finding a cube root. Okay, remember, always check the answer, that is multiply 45 into 45 into 45 and check. Okay, now we have to find out the cube root of this number. Okay, which is 91125. Now, starting from the left side, make pairs 1, 2, 3 and this one. So, this is group 1. 5 it as unit place, that means, you know, the cube of 5 is 125, 5 comes at the unit place. So, here 5. Now, 91. Now, 91 comes between 64, which is a 4's cube, and comes between 125, means 5's cube. So, 91 is greater than 64 and less than 125. So, we will write here 4. Isn't it easy and very simple? Okay, but always check the answer, okay, if you are not sure. Let's do exercise 7.2. Find the cube root of each of the following by prime factorization. Okay, so the number is 10648. Okay, 2 5s are 10, 2 3s are 6, 2 2s are 4 and 2 4s are 8. Okay, 2 2s are 4, 2 3s are 6, 2 6s are 12, then 2 6s are 12 and 2 2s are 4. 2 1s are 2, 3 3 1. Okay, now 11. 11 1s are 11. 11 2s are 22, then 11 1s are 11. 11 11s are 121 and 11 1s are 11. So, make the pair. 2 into 11 is 22. That means cube root of this number is 22. Okay, students. Now, you will do practice of this chapter.